Force and pressure. Force, a push or a pull. In our daily life, we pick up things, open things, shut things. These actions can be classified as pushes or pulls. Moving a loaded cart is the action of pushing, opening a drawer is the action of pulling, and drawing a bucket of water from a well is the action of lifting. In science, a push or a pull on an object is called force. Forces are due to interaction. The concept of force gives us the quantitative description of the interaction between two bodies or between a body and the environment. Thus, the interaction between two bodies is called force. When you push or pull a car stuck in mud, you exert a force on it. This force may or may not be able to move the car. Thus, force is an agent, often termed as a pull or a push, which can move or tend to move an object, can stop or tend to stop an object in motion, can change or tend to change the direction of motion of an object, can increase or decrease the speed of an object. Effects of force. A force can change the state of motion. If we push an already moving ball, it begins to move faster than before. But if you place your palm in its path, allowing the ball to touch your palm gently, and remove your palm as soon as the ball touches it, the motion of the ball will change. You will see that it slows down. When a force is applied to a body in the same direction, its speed increases, and when it is applied in the opposite direction, its speed decreases. In other words, a force can increase or decrease the speed of a body. Force can change the direction of a moving object. In the game of cricket, the direction of motion of a ball is changed when the player hits the ball with his bat. When a force acts on a body, it may change its speed and change its direction. Force can change its state of motion into state of rest. This is because the state of motion of a body is described by its speed and its direction of motion. The state of rest is a state of zero speed. An object may be in a state of motion or a state of rest. Both these states are its state of motion. Therefore, any change in its speed or direction means a change in its state of rest. Example: a moving object can be made to stop by applying a force. Force can change the shape of a body. If a ball is squeezed, there is a change in its shape. Thus, a force not only can change the state of a body, but it can also change its shape. Classification of forces. Contact forces. Most of the time, when a force is applied on an object, it is in physical contact with the agent applying the force. You cannot lift a bucket without holding it. The force resulting due to the action of muscles is called muscular force, like walking, bending, running, etc. Muscular force. We use the muscular force of animals to haul heavy loads, pulling carts, plowing, and many other tasks. Muscular force can be applied only when there is physical contact between the object and the agent which applies force. Thus, the force between two bodies when they are physically in contact is called a contact force. Examples of such a force are frictional force and force acting between two bodies when they collide. Some of the contact forces are frictional force. This is a contact force which comes into play when a body slides or tends to slide on another body, only when there is relative motion between two bodies. If the bodies are at rest, there is no force of friction between them. When you roll a ball on the floor, it comes to rest after traveling a certain distance, although you do not apply force to stop it. A force does not seem to act, but still the motion of the body stops. A body cannot stop by itself. To stop a body, a force has to be applied on it in a direction opposite to the direction of its motion. This is the force we call friction. Normal reaction. When a body is pressed against a rigid surface, the body experiences a force which is perpendicular to the surfaces in contact. This force is called the normal reaction. It always acts perpendicular to the two bodies in contact. Tension. When a body is suspended from a string, the string becomes taut. To balance the weight of the body, a force comes into play in the string which opposes the weight. This force developed in the string is called the force of tension. Tension always acts on a string towards the point from which the string is suspended. Forces during collision. When two bodies collide, they exert forces on each other. These two forces are always equal and opposite. This force acts for a short time and is responsible for making the bodies move apart after collision. Non-contact forces. The force between two bodies which are not in physical contact is called a non-contact force. Some examples of this type of force are gravitational force, electrostatic force, and magnetic force are also called as field forces or action at a distance force. Magnetic force. The force of interaction which exists between two magnetic poles is called magnetic force. It extends to infinity. The magnetic force between two like poles is repulsive, while between two unlike poles is attractive. The magnets need not be in contact to apply a force on one another. Electrostatic force. The force of interaction which exists between two charges is called electrostatic force. It too extends to infinity. The electrostatic force between two like charges is repulsive, while between two unlike charges is attractive. The same result is observed when you run a dry plastic comb through your dry hair and bring it close to pieces of paper. The pieces of paper will be attracted by the comb. This force, as you see, does not require any physical contact. Gravitational force. The force of interaction which exists between two particles due to their masses is called gravitational force. It is the force which binds the entire universe and is not restricted to objects lying on the earth. This force keeps objects bound to the earth and give rise to what we commonly call the weight of an object. This force is always attractive in nature and extends to infinity. It is a very weak force. It becomes appreciable only when the objects are very large, like the earth, moon, sun, and the stars. Pressure and force. Cyclones and winds are caused due to the difference in pressure at different points. We can relate this pressure with force. Relation between force and pressure. When a hammer strikes a sharp nail, we find that it readily enters the wood. The same cannot be said about a blunt nail, although the hammer applies the same force on the nail in both the cases. The pressure acting on the two nails is different. When we apply a force on a body, it may act in any angle. When a nail is driven into a block of wood by a hammer, the force acts normal, perpendicular to the surface of the nail. The force acting normally, perpendicular, on a surface is called thrust. Thus, thrust is a vector quantity and is measured in the units of force. The thrust acting on a unit area of a surface is called pressure. To find pressure, therefore, we need to divide force by the surface area on which it acts. So pressure is equal to thrust upon area. If the area of contact is more, then for the same force, pressure is less. Atmospheric pressure. The gaseous envelope surrounding the Earth is called atmosphere. Due to its mass, the atmosphere exerts a force on the Earth's surface. The force exerted by Earth's atmosphere per unit area of Earth's surface is called atmospheric pressure. It is estimated that the pressure exerted by the Earth's atmosphere has a value of 1 lakh Pascal. We do not feel this tremendous pressure due to the atmosphere because our blood contains dissolved oxygen at a pressure slightly more than the atmospheric pressure.